Hello everyone, this is Rogério here. I'm the OJP founder, and today I'm going to be showing you a test on the newest feature of OJP, the OJP Cluster. Okay, so we're going to start the test with two OJP server instances, two OJP proxy server instances. We're going to start the slow query segregation test modified to point to two instances and to run for 4 minutes and actually 80 threads, just to keep it a bit busier. During the test, I'm going to be killing one of the servers. Okay, we're going to be monitoring how many connections are open to the database during this time, and we're going to restart that server that we 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 killed. So we're going to bring it back up. Then we're going to be killing the other OJP server, and we're going to bring it back as well. Okay, the expectation for this test is that the number of connections adapt during servers going down and up and remains the same during the test. Okay, it might vary for a little while, but the expectation is that it adapts, and once it recognizes that one of the nodes is down, it re-escalonate the connections of the other server. Okay, so let's start by looking at what did we have to change here to start this test. Basically, from what we have in our current repo, we just increased the minimum idle number of connections there to 20, so it's easier to visualize. As we are going to be running two OJP servers, each one should open 10 connections initially. Once we kill one, that connection should drop momentarily to 10, and eventually that server should rise up the number of connections to 20 by itself, so accounting for the 10 of the server that has just been killed. And the same when we restart the server, it should decrease. It should probably rise up to 30 for a little period and decrease immediately back to 20. Now we're going to be doing this with both servers, right? So we're going to kill one server, bring it back up, kill the other server, bring it back up during this 4-minute test. So what else we changed? The POM don't bother, like that change that is there is not related to this test. So in the Postgres connection CSV, which is the CSV file that we use to get our connection to the database, we modified what we currently have in the repo to have two nodes, right? One in each port here, one in port 10591 and one in 10592. They're going to be all running in my machine, right? And the test itself, what we modified, we just added more threads and more time, okay, from what is currently in our CI/CD pipeline running constantly as a test. This test runs a variety of queries, like CRUD queries, and it's a reasonable test to be done. And it seeds the database before starting with thousands of records, so it's not an empty database. It's a good test to check things. So let's start then the test. Let's first take a look what is I have running here. Docker PS. So we see that Postgres is running, okay. So let's now connect to bash program inside this Postgres image, a container. And there inside we're gonna connect to Postgres, right? So now we're inside Postgres. We're gonna use this select to see activity in the database. Currently there is only one connection to the default DB, which is the database we're gonna be using, which is the connection I'm using here to monitor, okay? So we're gonna be starting now one of the servers. It started correctly, healthy, no issues in the logs. Let's start the second one. Also, it started correctly, no issues in the logs. Now we're gonna start our slow query segregation test, okay? So that's now starting. Let's check the logs here. Let's just wait for the seeding first, because the seeding is not part really of the test, and now the test is running, right? So let's just check that both servers are receiving requests, which is the case here, and let's check how many connections are open. 20. That's a very good sign, because that means that each server opened 10 connections to the database, and the total is correct, is in 20. the first part of the test, we're going to be killing the first server. So that's dead now. We can see here that it is dead. The second server is taking all the load at this point, and we can see that the client is working fine. The client did identify that now is just one server of two, and we're gonna see what that produced here in terms of connections. So 22 connections, that means the remaining server increased its pool to 20, right? It received the information that the other node went down, and the cluster remains at its ideal number of connections. So we're gonna be bringing back this server here. I'm gonna be quick here to show you if we can catch the change here. Sometimes it's not possible because it's super quick. And I think that's the case here. We couldn't catch. Sometimes you can see that it goes to 30 real quick and decreases back to 20. Let's just make sure that both servers are receiving requests, which is the case here. And let's make sure also that the client now knows that there are two servers. So in the logs, we can see logs like this. These logs are info, right? In production, you're not going to have so verbose logs. But that's the expectation. Now, let's stop the second server and let's go quickly here. So we see that the connections drop because we just killed the server, right? So let's wait a few seconds and we should see the connections go back to 20. Usually for this test, we don't need that many connections, so it is visible that the pool is not that eager to create the connections back. But you see now it's back to 20. I even when I had a mean idle smaller, like the 2 connections, I saw that it wouldn't create more connections because it doesn't really need. It would need a much more load to really need more connections. So that might explain why it takes a little bit of time to actually raise up the connections. Let's restart now the server that is just gone down. Here it is. The server is back up. Let's make sure that the test is still going. Let's make sure that the server that just resurrected is back online. And let's check the number of connections to the database. It remains 20, which is exactly what we wanted to see, right? So I think we have a bit more time. Let's kill the second server again, just for fun. Let's just see connections going down. As soon as they come back up, I'll restart. I'm not sure if I will have time to do that, but just to do a bit of chaos monkey engineering here. And it's still going. Yeah, it's raising 20 connections now. Let's bring it back up and quickly come back here to see if we can get the. Yeah, it's really fast because sometimes I can catch it going to 30 and back to 20. In this test I couldn't because it really adapts fast to the correct number of connections. The test is done. So the result of this test, what is looking for here is 0 failures, right? It's not guaranteed to have 0 failures when we are killing servers, okay? It's expected that maybe a few transactions that are long-running transactions might fail. So this is not guaranteed that all the time we would have 0 failures. But it's consistent, and in this test with this load, it's 0 in most of the times. I think I have one test that one query failed in like 5 tests like this that I did. All right, so this is our new cluster capability in OpenJ Proxy. If you want to know more about it, come to our GitHub page. Here we have a lot of documentation about it, and you can learn much more about it. Okay, I hope you enjoyed it. See you next time.